Hello, I'm back. So this is in order to figure out part B. This is going to be part 2 of the video. So what you have to do for part B is you have to use the answer from part A, and you have to go from moles to molecules. Okay, so I'm going to show you how to set that up, and I'm going to show you. I include an infographic in order to show you how to set up the problem so you can get the correct answer. I'm going to show you how to use that too. Okay, so let's go back to the board. Give me a second. So basically, in part B, I'm going to read the question to you. How many molecules of ibuprofen are in the bottle? So how do you know that, right? Well, this is what they're asking for right here. How many molecules are in the bottle? Okay, and this is C13H18O2. This is the ibuprofen. This is what they're talking about. So from part A, you know that there are this many moles in it, but then how do you go from moles to molecules? That's where you use the infographic. So that's what this is right here. So you're at this moles part right here, and you want to get to particles. Well, you got to follow the arrow. You got to go from the tail to the head of the arrow. So what you got to do is you got to take the moles times Avogadro's number, which is what we talked about before. Okay. So how do you set it up? Once again, the information that they give you goes in the upper right-hand corner, and you can set it over 1 like this. So this right here is the answer from part A, and this is going to be 0.16 moles of ibuprofen. Okay, so if moles goes up here, moles have to go down here in order to cancel out. Okay. Sorry about the camera. I'm learning how to use it. Okay, so in 1 mole of anything, how many molecules are there? That's where Avogadro's number comes in. Okay. So 0.16 times this number right here will get you the correct answer. Also, when you put this in the calculator, make sure you use parentheses, okay? Because otherwise it's going to take this number times this number and then raise it to the 23rd power, and you don't want that. You want to use this whole number as one group times this number, and it's going to tell you how many molecules there are. So you get the calculator, and it's 0.16 times open parentheses 6.022, and then give me a second. I need 1 minute. I need 1 minute. Okay. So it's going to be 0.16 times 6.002, and then the E stands for exponent, and it's going to be to the 23rd power. Hit enter, and this is going to be the number of molecules that are in 33 grams of ibuprofen. Okay. And then also, when you have all these numbers, where do you round to once again? Okay. They only gave you only started with 2 significant digits when you started this problem. That's the least accurate number that you had. So should only be 2 significant digits in the answer. Okay. So it's going to be 9.6 times 10 to the 22nd power molecules of C13H18O2. And this is the answer to problem B. Okay, let me adjust the camera. Okay, and that's how you do part B.